Greetings from Fairbanks, Alaska. I'm Jen Delamere, Director of the Geographic Information Network of Alaska, or GINA, on the University of Alaska Fairbanks campus. GINA's primary mission is to provide near real-time operational satellite products to Alaska's researchers and forecast groups that include the National Weather Service, the Alaska Fire Service, and the Alaska Volcano Observatory. We also provide many of our images via a public web portal. GINA achieves its mission by operating 2 direct broadcast antennas in interior Alaska, receiving data from 9 polar orbiters. We also have access to data from a NESDES antenna in Utqiagvik. Our products are delivered to our stakeholders within 15 to 30 minutes of a satellite overpass, depending on the product. This is all made possible by broad support from the JPSS program. So what is this image I'm presenting on my title slide? It's a dayland cloud RGB created from VIIRS that flies aboard the JPSS fleet. In this image, snow and ice appear as a cyan color, while water clouds are white. Very high ice clouds are also cyan colored. And why did I select this image to show you? In short, it's just an astounding image from mid-October. In this presentation, I will take you through the process by which this image was generated and distributed into the computers and iPhones of Alaskan stakeholders. The image I just showed was created using VIIRS data that was received by an antenna within this radome. We affectionately call the antenna, located on the UAF campus, Big Dog. One of the key features of receiving data in Alaska is that near real-time imagery and derived products are delivered much faster to forecasters than if we had to wait for global data dumps. Data from an individual pass is consumed into GINA's near real-time processing stack, that is, a couple of big racks of fast computers. Our operations dashboard shows the flow of data from arrival to product creation. Each satellite we receive has a different workflow with different software packages. After pass arrival, raw data is converted to a usable data product. Then onto the creation of sensor data records using SIMS Community Satellite Software Package, CSPP, for a selection of sensors. From there, we create GeoTIFFs, SCMIs, CleverX Cloud products, MERS precipitation products, and NewCap soundings. Products are sent to the National Weather Service Alaska region via a local data manager so that they can be viewed in AWIPS by the Fairbanks, Anchorage, and Juneau WFOs. A selection of GeoTIFFs is delivered to the public via our Puffin Feeder web portal. Puffin Feeder is populated with images around the clock, and you can visit anytime at feeder.gina.alaska.edu. So returning to that VIIRS image, it was shared on the National Weather Service Fairbanks Facebook page. That page has 16,000 followers. Creation and distribution of such products occur at GINA over 100 times per day. Well, except the Facebook posting part. 100 plus passes per day, 80,000 plus products, and in near real time. Why do Alaskans need all of this? A UAF student, Jill Shipman, and GINA's satellite liaison, Carl Dierking, have a good answer to this question.
Alaska is a vast land. It is the largest state in the U.S., around 1/5 the size of the contiguous U.S., with more coastline than all other states combined. It has many of the highest peaks in the United States, including Mount Denali, the highest in North America. Glaciers cover almost 5% of the state. Although Alaska is large, observations are scarce. Compare these 2 images showing the scarcity of temperature observations in Alaska versus the contiguous U.S. Radar coverage is also much more limited than the rest of the country. Polar satellite data helps fill these observation gaps.
GINA utilizes 2 JPSS satellites as well as 8 additional polar orbiters to deliver a wide array of products. Imagers create 2-dimensional images of an area with incredible detail. VIIRS, an example of such an imager, has a spatial resolution that varies from 375 meters to 750 meters, depending on the spectral band, and with its large swath, we see 16 to 18 VIIRS views of some point on the northern coast of Alaska per day, 10 to 14 views for central interior Alaska, and 6 to 8 views for southeast Alaska. GINA generates cloud products from the images using the CloudRx software, made available by the University of Wisconsin SIMS team. Derived quantities include cloud mass, cloud type, and cloud height. These parameters are particularly useful to specialized aviation forecasters. GINA is also producing Microwave Integrated Retrieval System, or MEIRS, rain rates and snow and ice products. Currently, Carl Dierking is working with meteorologists and researchers to compare MEIRS rain rates with several other available products. Results from that study will be available this winter and are relevant to the JPSS hydrology initiative. And as of fall 2020, GINA is now creating snow, ice, and wind products from AMSR-2, a microwave instrument flying aboard GCOM-W. Add in the sounders and you gain the ability to create vertical profiles of temperature, humidity, and trace gases. One such set of soundings is derived from the NOAA Unique Combined Atmospheric Processing System, or NUCAPS. As there are just 13 Alaska NWS offices that release balloon-borne soundings over a state 1/5 the size of the continental U.S., the NUCAPS profiles, created from a combination of IR and microwave data, greatly increase our ability to identify layers of atmospheric instability, intense cold, and air aloft that can freeze fuel and jets. We currently provide NUCAPS from SNPP and NOAA 20 to the National Weather Service Alaska region and are on the verge of releasing NUCAPS from MEDOT B and C. With this, we will have soundings nearly every hour for some fraction of the state. So while I've shown you the flotilla of sensors and satellites used in GINA operations, I'll now show you the fleet of facilities that receive all this data. Big Dog is a C-Space X-band antenna installed in 2001 on the UAF campus. It primarily receives data from Terra, Aqua, and secondarily the JPSS satellites. We work with our stakeholders to prioritize what passes to receive on which antennas to maximize our product selection. In 2015, with funds from the Sandy Hurricane Supplemental, a 3-meter XLS-band orbital systems antenna was installed at the NOAA FCDAS facility just outside of Fairbanks. This antenna is Big Dog's companion and is known as Sandy Dog. Sandy Dog keeps us very busy receiving passes from 9 polar orbiters. While GINA UAF owns the antenna, the FCDAS staff greatly facilitates its operation. Finally, a NESDIST-owned facility located in Geographic, Alaska, provides NOAA 18 and 19 data to GINA. The passes received from the Geographic antenna have the advantage of a wider coverage of the Arctic Ocean. What GINA achieves is only made possible because incredible people have created extensive physical infrastructure and software packages to do all this work. In particular, I'd like to acknowledge SIMS at the University of Wisconsin, CIRA at Colorado State University, as well as NASA Sport, George Mason University, and the City College of New York for helping GINA do what it does. And thank you to the incredible GINA team who works 7 days a week to keep the data flowing. Direct broadcast capabilities are key to meeting the goals of JPSS Proving Ground and risk reduction initiatives. Just about every initiative is relevant in Alaska. This graphic highlights some of the important activities in Alaska's interior, along Alaska's coast, and the adjacent oceans. For the remainder of this presentation, I'll focus on the JPSS Arctic Initiative, whose motto is Preserving Life Pole to Pole. The JPS missions have brought awareness of the Alaska environment to a new level with stunning imagery from the VIIRS sensor. I asked Rick Toman, an expert in Alaska and climate weather, to give me his assessment of the role of social media in Alaska. Rick emphasized that sea ice, or the lack thereof, impacts the life of every northern Alaskan. Most of rural Alaska has limited bandwidth, so information has to be delivered in ways that citizens can receive. Smartphones with Facebook and Twitter are key to communications. Rick frequently pulls VIIRS and MODIS imagery from GINA's Puffin Feeder web portal. He then labels the images with key features and shares on Facebook and Twitter. In a November 14th post, Rick shared a VIIRS image and points out where the ice is and isn't. It is in Norton and Golovin Bays, it is growing in Kotzebue Bay, and there is open water north of Deering. Rick got immediate response from local folks sharing their observations of the water and ice just outside their doors. This is just one example of many in which satellite imagery is making inroads into the lives of everyday Alaskans. I'm pivoting now to show you two 2020 research projects on sea ice that benefited from near real-time imagery created at GINA using JPSS products. First, the United States Navy's ICE exercise, or ICEX, is a biennial exercise conducted above the Arctic Circle. ICEX provides submarines the opportunity to train in an operationally challenging environment. Sea ice expert Lou Shapiro utilized GINA's puffin feeder images to monitor lead patterns in the Chukchi and Beaufort Seas and to identify patterns likely to result in ice deformation near Camp Sea Dragon. A VIIRS thermal image from March 15th illustrated some fantastic ice features, some quite close to Camp Sea Dragon. In Dr. Shapiro's words, a prominent system of arcing leads opened across the mouth of the Amundsen Gulf when the pack ice was forced in that direction. Opening east of Herschel Island attests to the pack ice movement in that direction, and flows within the shear zone along the coast were also found to have moved eastward during an earlier storm. The smaller, more isolated openings in the ice were probably the result of local differential movement between flows in a compressive environment, rather than the larger displacements that occur when the pack is less contained. In short, did Camp Sea Dragon have to evacuate? No, they didn't, and the experiment went on. Dr. Shapiro appreciated the frequency of the images coming from the polar orbiters. This type of image analysis was repeated every day of the campaign. And one more Arctic demonstration. The RV Sikuliaq is an oceanographic research vessel capable of cutting through ice 2.5 meters thick. This fall, the Sikuliaq was on an Arctic Observing Network NSF mission to study Pacific origin water flowing northward through the Bering Strait and its impact on the ecosystem. The Sikuliaq operations team retrieves VIIRS imagery from an automated fetch script off a GINA server and imports the images into their own map server. UAF's Steve Roberts provided material and text for these slides. On October 28th, the Sikuliaq was transiting along the Alaska North Slope heading into Canada for an oceanographic survey of the Mackenzie Canyon. However, their path was being blocked by a large multi-year ice flow. This is a true color VIIRS image overlain with a real-time ship track, which assisted with the decision to sneak around the south end of the flow. The Sikuliaq team also uses SAR images, but the temporal coverage of SAR is limited. But the combination of SAR and visible imagery helps track these flows and leads even when the visible scenes have partial cloud cover. Later in the cruise, as the crew lost daylight, ship operations began to rely more on VIIRS day-night band imagery. As they headed west, they needed to find open water. With a significant gap in SAR coverage, the VIIRS images were their only source of information regarding real-time sea ice coverage. Luckily, the weather was clear enough, and with the shine of the moon, a course to open water was charted. And for our JPSS Arctic Initiative partners, such as the Alaska Sea Ice Program at the National Weather Service, a load of new products from the AMSR-2 microwave sensor flying aboard GCOM-W are now available. AMSR-2 imagery products include ocean wind speed, rain rates, sea surface temperature, snow depth, snow water equivalent, and sea ice concentration. AMSR-2 products are not yet available in AWIPS format, but this is the next step when we can coordinate with the CSPP Polar to Grid update. I've covered a lot of ground in this presentation, but you don't have to remember it all. GINA's website will point you to links for data products, training videos and briefs, and specific project resources for the JPSS initiatives. I also encourage you to listen to Pete Hickman's talk in this session for another GINA perspective. Thanks for viewing this presentation.